Hello, in this lecture we'll find out the length of line segment X. In the drawing we have a quarter circle, AOB is a quarter circle, and inside this quarter circle we have this semicircle, and we also know that side AO equals to 10 units in its length. Our mission is to find out the length of side AM that is equal to X. Okay, so first of all, because of the fact that AOB is a quarter circle, it means that this angle must be equal to 90 degrees. That is to say, angle AOB is a right angle, it is equal to 90 degrees. And side AO must be equal to side OB. Why? Because AO and OB, they are both the radii of this quarter circle, therefore they are equal to each other. So AO equals to OB, I write it down, AO equals to OB, and both of them are the radii of this quarter circle. So I write it down, AO equals to OB, they are both the radii of the quarter circle. Therefore, they are equal to each other. But AO equals to 10 units, therefore, from this equation we derive that OB will be also equal to 10 units. So the radius OB of this quarter circle equals to 10 units in its length, but the radius OB of the quarter circle is also the diameter of this semicircle. So the diameter of this semicircle is OB, that is equal to 10 units. Therefore, the radius will be equal to 10 over 2, that is 5. So we define the center of this semicircle as P. OP is the radius of this semicircle, that is equal to 5 units. Likewise, PB is also the radius of this semicircle, and therefore PB equals to 5 units. We define the point of tendency of tangent AM with this semicircle as Q. In the next step, we join points P and Q together by a straight line. Point P is the center of this semicircle, point Q is a point on the semicircle itself, therefore PQ is the radius of this semicircle, that is equal to 5 units. Again, point Q is the point of tendency of tangent AM with this semicircle. And PQ is the radius of this semicircle. We have the radius PQ that is drawn to the point of tendency. That is to say, it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then the radius PQ will be perpendicular to the tangent AM. So if PQ is perpendicular to AM, it means that this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Okay. In the next step, we will extend side OB and side AM by a straight line until they touch each other. will define the touching point of the extended side AM and side OB as point N. We will focus at point A. Point A is a common external point in relation to this semicircle. Why? Because point A is not located on the semicircle and it is not located inside the semicircle. Therefore, point A is a common external point in relation to this semicircle. From the common external point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, the lengths of two tangents from a common external point to a circle are equal. That is to say, AO equals to AQ. But AO is 10, therefore AQ must be also equal to 10 units in its length. Okay, so we will define angle ANO. This angle is theta. And we will focus in the right triangle, triangle AON. In the right triangle, triangle AON, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. In the next step, we focus on the right small triangle PQN. This right small triangle PQN, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. So write it down. The missing angle here equals to 90 degrees minus theta. In the next step, we will prove that the right big triangle AON is similar to the right small triangle PQN. So I write it down. We will prove that the right big triangle AON is similar to the right small triangle, triangle PQN. So why the big right triangle is similar to the small triangle PQN? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So angle AON, this angle is angle AON. That is equal to this angle, that is actual angle PQN. The small right triangle. Repeat again. Angle AON in the right big triangle AON is equal to angle PQN in the right small triangle PQN. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this angle theta is a common angle that belongs to both triangles. So can I know that angle theta equals to itself? If we relate to angle theta as it is belongs to the big right triangle AON, which will be angle ANO. And it is equals to angle theta itself. If we relate to angle theta as it belongs to the small right triangle PQN, it will be angle PNQ. It is a common angle that belongs to both triangles. Repeat again. This equation means that angle theta equals to itself. Okay, angle theta is a common angle that belongs to both angles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle OAN. And it is equals to, angle OAN belongs to the big triangle AON, and it is equals to this angle, this actual angle QPN in the small triangle. Repeat again. Angle OAN in the big right triangle is equals to angle QPN in the small right triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles of the right big triangle AON are correspondingly equal to all the three angles of the small right triangle PQN. Therefore we actually proved that the right big triangle AON is similar to the small right triangle QPN according to angle similarity rule. So I write it down. We actually proved that the right big triangle AON is similar, this is the sign of similar, to triangle PQN according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that AO in the big right triangle, side AO in the big right triangle AON over AO over QP in the small right triangle QPN equals to AN in the big right triangle AON over PN in the small right triangle QPN and it is also equals to QN in the big right triangle AON over it is actually ON. This is side ON in the big right triangle AON over PN in the small right triangle QPN. Again, ON in the big right triangle AON over Q over PN in the small right triangle QPN. Repeat again. From the fact that those two right triangles are similar to each other, or from the fact that triangle AON is similar to triangle QPN, we will derive that the following relationship exists between their sides. That AO over QP equals to AN over PN equals to QN over ON. It's actually ON over QN. ON over QN. Repeat again. AO over QP equals to AN over PN equals to ON over QN. AO equals to 10 over OP equals to 5, and it is equals to AN. What is the length of AN? AN equals to AQ plus QN. Again, AN in total equals to AQ plus QN. So substitute AN by AQ plus QN over PN. PN equals to 5 plus BN. Again, PN in total equals to 5 plus BN. So if we're going to find out that 10 over 5 equals to AQ plus QN over 5 plus BN, and it is equal also to QN, to ON. ON equals to 5 plus 5 plus BN. Again, ON in total equals to 5 plus 5 plus BN. 5 plus 5 is 10, so it is 10 plus BN. ON equals to 10 plus BN over QN. Over QN. So in conclusion, found out that over 5 equals to AQ plus QN over 5 plus BN, and it is equals to 10 plus BN over QN. So we'll get the first equation from this equality. 10 over 5 is 2, so 2 equals to AQ plus QN. AQ is 10 plus QN, so AQ is 10 plus QN over 5 plus BN. This is the first equation. In the next step, those two expressions are equal to each other, so we create the first equation from those two equations, from those two expressions. This will be equation number 2, and we get that according to equation number 2, actually we create those two expressions are equal to each other. That is to say, 2 equals to 10 plus BN over QN. Here we multiply equation number 1. We cross multiply this equation number 1, and we get that according to equation number 1, 2 times 5 plus BN equals to 10 plus QN. We'll open the brackets on this side of this equation number 1, and we get that according to equation number 1, 2 times 5 is 10 plus 2BN equals to 10 plus QN. We have 10 on both sides of the equation, so 10 will get cancelled. And finally we get that according to equation number 1, 2BN equals to Qn. That is to say, Qn equals to 2Bn, according to equation number 1. We have in equation number 2, we cross multiply equation number 2, and according to equation number 2, we get that 2 times Qn equals to 10 plus Bn. So according to equation number 2, 2 times Qn equals to 10 plus Bn. Here we substitute Qn by 2 times Bn, because according to equation number 1, Qn equals to 2 times Bn. And we get that 2 times Qn is 2 times Bn, equals to 10 plus Bn. 2 times 2Bn is 4Bn, so 4 times Bn equals to 10 plus Bn. We subtract Bn from this equation, equation number 2, and we get that 4 times 4Bn minus Bn is 3Bn, so 3Bn equals to 10. Here we divide this equation, equation number 2, by 3, and finally we get that Bn equals to 10 over 3. We found out that Bn equals to 10 over 3. You can write down in the original drawing that this line segment Bn equals to 10 over 3 units. But according to equation number 1, Qn equals to 2Bn. Again, according to equation number 1, we found out that Qn equals to 2 times Bn. And just right now found out that Bn equals to 10 over 3. So Qn equals to 2 times, and Bn is 10 over 3. Therefore, Qn equals to 2 times 10 is 20 over 3. Found out that Qn equals to 20 over 3 units in its length. So we can write down in the original drawing that Qn, this line segment Qn, equals to 20 over 3 units in its length. In the next step, we define Qm as A. What is the length of Mn? Mn equals to Qn minus Q. Nm equals to Qn minus Qm. Again, Qn minus Qm. Qn minus Qm equals to Mn. It again, Mn equals to Qn minus Qm. So Mn equals to Qn, that is 20 over 3, minus Qm, that is A. So in total, Mn equals to 20 over 3 minus A. 20 over 3 minus A. Okay, in the next step, we will complete this quarter circle to a circle. So we completed the quarter circle to a circle, and we'll extend BO by a straight line until it touches the circle. We'll define the touching point of the extended side BO with this circle as point C. Point O is the center of the circle. Point C is the point on the circle itself, therefore OC is the radius of the quarter circle. The radius of the quarter circle equals to 10 units in its length, therefore OC equals to 10. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 14. According to rule number 14, rule number 14 is true in any circle. So in any circle, if we draw two chords A, B and C, D from the common external point P, then the following equation will be true. PA times PB equals to PC times PD. So we have in the drawing a circle, and we have the common external point, point P. Point P is the common external point in relation to this circle. Why? Because point P is not located inside the circle, nor on the circle itself. Therefore, in relation to this circle, point P is an external point. So from point P, if we draw line segment PB, we created here chord AB, and from the same common external point, point P, we will draw another line segment PD. In this way, we created chord CD. So in this drawing, the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing, we have the common external point, point A. From the common external point, point N, we have line segment NC. Line segment NC creates chord CB, and from the same common external point, point N, we have line segment NA. Line segment NA creates chord AM. Therefore, all the requirements of rule number 14 are met, and we get that according to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. So I write it down. So if we focus on the common external point, point N, according to rule number 14, NB times NC equals to NM times NA. repeat again. If we focus on the common example point A, according to rule number 14, NB times NC equals to NM times NA. NB is 10 over 3 times NC. What is the length of NC? NC in total equals to, or CN equals to CO plus OB plus BN. That is to say, NC equals to CO, that is 10, plus OB, that is 5 plus 5, that is also 10, plus BN, that is 10 over 3. So 10 plus 10 is 20, plus 10 over 3. So in total Cn equals to 20 plus 10 over 3. And it is equals to Nm. Nm is 20 over 3. Nm equals to 20 over 3 minus A. Here, Nm equals to 20 over 3 minus A. Again, this line segment Nm equals to 20 over 3 minus A. Times Na. What is the length of Na? Na equals to AQ plus Qn. Again, Na or An equals to AQ plus Qn. AQ is 10 and Qn is 20 over 3. So in total An equals to 10 plus 20 over 3. In conclusion, we found out that An equals to 10 plus 20 over 3. So according to rule number 14, we found out that 10 over 3 times 20 plus 10 over 3 equals to 20 over 3 minus A times 10 plus 20 over 3. So here we multiply 20 by 3 and then we divide it by 3 and we get that 10 over 3. 20 times 3 is 60 and 60 plus 10 is 70. So in total this expression equals to 70 over 3 and it is equals to, here we multiply minus A by 3 and then we divide it by 3 and this expression in total will be equal to 20 over 3 minus 3A times, here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor of this expression. 10 times 3 is 20, 10 times 3 is 30, and 30 plus 20 is 50. So in total, in the numerator we have 50 over 3. In conclusion, we found out that 10 over 3 times 70 over 3 equals to 10 minus 3 over 20 over 20 minus 3A over 3 times 50 over 3. 3 times 3 is 9 and here also 3 in the denominator we have 3 times 3, that is 9. So in both sides of the equations, in the denominator we have 9, so we multiply this equation by 9. In this way we cancel those two 3's and we left only with 20 times 70, that equals to 20 minus 3A times 50. Here we divide this equation by 10 and finally we get that here 10 we get cancelled and we left only with 70. So 70 equals to 20 minus 3A and 50 over 10 is 5. So in conclusion, we found out that 70 equals to 20 minus 3a times 5. We'll open the brackets on this side of the equation and we'll get that 70 equals to 20 times 5 is 100, minus 3a times 5 is minus 15a. So we found out that 70 equals to 100 minus 15a. We subtract 70 from this equation and we get that 0 equals to 100 minus 70 is 30, minus 15a. We'll add 15a to this equation and we get that 15a equals to 30. We divide this equation by 15 and finally we get that a equals to 30 over 15 is 2. So a equals to 2 units in its length, and here a equals to 2 units in its length. Our mission is to find out the length of AM, that is x. Again, AM, our mission is to find out the value of x that is actually equals to AM. AM equals to AQ plus QM. Again, AM equals to AQ plus QM. AM equals to AQ plus QM. That is to say, AM equals to AQ, that is 10, plus QM, that is A. That is to say, x equals to 10 plus A. So x equals to 10 plus A is 2. 10 plus 2 is 12. So in conclusion, found out that x equals to 12 units in its length. Okay, so this line segment AM that is equal to x is equals to 12 units in its length. And this is the answer to our question. In the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment AM is equal to x. So, in the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle AOB, we have a semicircle. This is a semicircle. We also know that AO equals to 10 units in its length. Again, our mission is to find out the length of this line segment AM that is equal to x. Okay, so first of all, because of the fact that AOB is a quarter circle, it means that this angle must be equal to 90 degrees. And AO and OB, they are both the radii of this quarter circle, therefore they are equal to each other. But AO equals to 10, therefore OB must be also equal to 10. And OB is the diameter of this semicircle, and if the diameter OB equals to 10, it means that the radius of this semicircle will be equal to 5. So OP, that is the radius of this semicircle, equals to 5 units, and P beta is also the radius of this semicircle, equals to 5 units in its length. We define the point of tendency of tangent AM with this semicircle as Q. The center of this circle is defined as P. We join points P and Q together by straight line. Point P is the center of the semicircle. Point Q is the point of the semicircle itself. Therefore, PQ is the radius of the semicircle, that is equal to 5. We have the radius PQ that is drawn to the point of tendency. Therefore, according to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. Then we extended side OB and side AM by straight line until they touch each other. Here we define the touching point of the extended two sides AM and OB is N. Okay. In this way we created the right triangle, triangle AON. This is the right big triangle AON. We define this angle as theta. Angle ANO equals to theta according to our definition. So if we focus on the right triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, if we focus on the small right triangle PQN, in the small right triangle PQN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Then we proved that the right big triangle AON is similar to the small right triangle PQN. Again, the right big triangle AON is similar to the small right triangle PQN. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, this is a common angle that belongs to both triangles, so angle theta equals to itself. And finally, those two angles they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the right big triangle AON are correspondingly equal to all the three angles in the small right triangle PQN. Therefore those two right angles are similar to each other according to angle similarity rule. Okay, repeat again. We proved that the right big triangle AON is similar to the small right triangle QPN according to angle similarity rule. And from the fact that the right big triangle AON is similar to the small right triangle PQN, we will derive that the following relationship exists between their sides. We will derive that AO in the big triangle over QP in the small triangle equals to AN in the big triangle over PN in the small triangle, and it is equals to ON in the big triangle over QN in the small triangle. AO is 10, QP is 5, AN, what is the length of AN? AN equals to AQ plus QN. Again, AN equals to AQ plus QN. Yeah. AN equals to AQ plus QN over PN. What is the length of PN? From the drawings it's very easy to see that PN equals in total to PB plus BN. PB is 5, so it is 5 plus BN. Again, PN in total equals to 5 plus BN. So here, PN equals to 5 plus BN, and it is equals to ON. What is the length of ON? ON equals to 5 plus 5 plus BN. That is to say, ON equals to 10 plus BN. Okay, ON equals to 10 plus BN over QN. So we have here a long equation. We created the first equation. Those two expressions are equal to each other. So this is the first equation. That is to say 10 over 5 is 2, and 2 equals to AQ is 10. So here we have in the numerator 10 plus NQ over 5 plus BN. This is the first equation that we created. Those two expressions are also equal to each other. We created from those two expressions that are equal to each other equation number 2. That is to say 2 equals to 10 plus BN over QN. So we have here two equations. Then we cross multiply this equation, equation number 1, and we found out that 2 times 5 plus BN equals to 10 plus QN. Okay, 2 times 5 plus BN equals to 10 plus QN. We open the brackets on this side of the equation number 1. We found out that 2 times 5 is 10 plus 2bn equals to 10 plus qn. Here we have 10 on both sides of the equation, so 10 will get cancelled and we left only with bn, and 2bn equals to qn. According to equation number 1, we found out that 2bn equals to qn. This is according to equation number 1. Here we have equation number 2. We cross multiply this equation and equation number 2 and found out that according to equation number 2, we actually multiply this equation and equation number 2 by qn, and found out that 2 times qn equals to 10 plus bn. Now we can substitute qn by 2 times bn, because according to equation number 1, qn equals to 2 times bn. Here we substitute qn by 2 times bn. Okay, so 2 times qn is 2 times bn, so it is 2 times 2bn equals to 10 plus bn. 2 times 2bn is 4bn, so 4bn equals to 10 plus bn. We subtracted bn from this equation number 2, and finally found out 4bn minus bn is 3bn, so 3bn equals to 10. We divided this equation number 2 by 3, and finally found out that bn equals to 10 over 3. Here, this line segment bn equals to 10 over 3 units in its length. And according to equation number 1, we found out that qn equals to 2 times bn. Again, according to equation number 1, qn equals to 2 times bn. So qn equals to 2 times bn, and bn is 10 over 3, so it is 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. So in conclusion, found out that qn equals to 20 over 3. This line segment qn equals to 20 over 3. Okay, then what is the length of mn? From the DOM it is very easy to see that mn equals to qn minus qn. Again, here, mn equals to qn minus qm. That is to say, nm equals to qn, that is 20 over 3, minus qm, that is equal to a according to our definition. So in conclusion, found out that mn equals to 20 over 3 minus a. If this line segment mn equals to 20 over 3 minus a. Okay. Then we completed this quarter circle to a circle, and then I presented to you rule number 14, and we implemented rule number 14 in our drawing. According to rule number 14, rule number 14 is true in any circle. So in any circle, if you draw two chords towards the circle from the common extent point P, and from the common extent point P, we draw those two line segments, PB and PD. In this way, we created chord AB and chord CD. So in this drawing, the following equation will be true: that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. You can actually implement rule number 14 in our drawing. Why? Because in our drawing, if you focus on the common extent point A and point N, from the common extent point N, we have line segment NC and line segment NA. Therefore, all the requirements of rule number 14 are met, and from that reason you can implement rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Repeat again. So, if you focus on the common extent point A, according to rule number 14, NB times NC equals to MN times NA. NB is 10 over 3. NC, what is the nerve of NC? NC in total equals to 10 plus 5 plus 5 plus 10 over 3. Again, NC equals to N to CO plus OB plus BN. CO is 10. OB is 10 plus 5 plus 5, this is also 10. Plus BN, that is 10 over 3. So in total, CN equals to 10 plus 10, that is 20, plus 10 over 3. So in total, NC equals to 20 plus 10 over 3. And it is equal to MN. MN is 20 over 3 minus A. MN is 20 over 3 minus A times AN. What is the nerve of AN? AN in total equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN, that is 20 over 3. So in total, AN equals to 10 plus 20 over 3. Then we multiplied 20 by 3, then we divided by 3. So this expression in total equals to 70 over 3. Here we multiplied minus 8 by 3, then we divided by 3 in order to overcome a factor with this expression. So this expression in total will be equal to 20 minus 3a over 3. Here we multiplied 10 by 3 and then we divided by 3 in order to overcome a factor with this expression. So this expression in total will be equal to 50 over 3. So we have 3 times 3 on both sides of the equations in the denominator. 3 times 3 is 9, so we multiplied this equation by 9 in order to eliminate the denominator, that is 9. And finally found out that, so 3 times 3 get cancelled here, and 3 times 3 will get cancelled because we multiplied this equation by 9. So in this side of the equation we left only with 10 times 70, and the other side of the equation we have 20 minus 3a times 50. Here we divided this equation by 10, so 10 will get cancelled, and 50 over 10 is 5. So in conclusion, found out that according to the equation, 70 equals to 20 minus 3a times 5. Here we open the brackets on this side of the equation and found out that 70 equals to 5 times 20 is 100, minus 3a times 15 is minus 15a. So we found out that 70 equals to 100 minus 15a. Here we subtracted 70 from this equation and found out that 100 minus 70 is 30 and 70 minus 30 is 0. So 30 minus 15a equals to 0. We added 15a to this equation and finally found out that 15a equals to 30. We divided this equation by 15 and finally found out that a equals to 2. Here, this line segment QM is equal to a equals to 2 units. And our mission is to find out the length of line segment AM. AM, that is x. Again, x equals to AM, x equals to AM, and AM in total equals to AQ plus QM. Again, AM equals to AQ plus QM. AQ is 10 and AM is A. So AQ is 10 and AM is A. So in total, AM equals to 10 plus A and A is 2. So in total, AM equals to 10 plus A and A is 2. So it is 10 plus 2, that is 12. So in conclusion, found out that AM is equal to AX, AM that is equal to X equals to 12 units in itself. Okay? Again, the line segment AM that is equal to X equals to 12 units in its length. Okay, thank you very much.